you know, I'm sure that you guys know how to find the zeros, right? And realize that sometimes zeros can have even multiplicity, odd multiplicity, right? The zeros with even multiplicity, the graph's supposed to reach that zero, but not crossing it, right? So basically it turns around. The odd multiplicities, then, you know, the graph's going to cross, right, at that zero. So we have two zeros. One is at -3/2, the other is at 5. And both of them are odd because you're looking at the power. Oops. Right? X plus 3/2 is the first power, and here the third power. Okay, so both of them will be crossed. Right? So therefore, see that you can sometimes just eliminate some irrelevant, you know, answers, right? Even odd, right? So touch. Okay, so it will be letter C, right? Crossing the two zeros. But let me ask you, what if I'm asking you the degree of this polynomial? What do you think the degree of f of x should be? Degree 4. You guys see that? The way you can count the degrees, if you have things like in a factor form, is to look at every factor. Here, x plus 3/2 is a factor, right? And it's the degree 1 factor because x is raised to the first power. Then you have x minus 5, that's the factor, but it's a degree 3. And the degrees of every single factor or the power of every single factor will add up. So this is a degree 4. Okay, so please understand how to count a degree properly. So things is different if you have, say, 3x to the third minus 4x squared minus 1. Then do you see that those things like 3x cubed, 4x squared, and a 1, they're not factors anymore, right? They're known as terms. Factors are the parts of the polynomial expression that gets multiplied together. But terms are the ones that are separated by addition and subtraction. If you're looking at terms, like, you know, over here, you're going to find the leading term, right? And the power of the leading term will be the highest power, and that power is the degree, right? Therefore, this is a degree 3, okay? That means now if you're looking at question number 3, of course, you know, knowing the fact that the number of turning points is the same as degree minus 1. But you have to tell the degree properly, right? So I might not show you a polynomial in terms of those terms, right? It might be factored like you saw in the first question. And therefore, in this case, you're looking at the leading term, right? Notice that leading term might not be the first term, right? They might, you know, intentionally scramble the order of the terms. So this guy is degree 3, and therefore, at max, I'm not saying that it must have, but at most, you can have 3 minus 1, which is 2 turning points. Okay, right, that's all you have to do. So please make sure that do remember some of the conclusions, and that's the whole point of, you know, I'm picking those problems to review in class. Okay. Now those are easy things. Let's just, you know, move on. So number 5. So I think that most people did very well in that quiz. So I think that now when it comes to graphing, at least the polynomials, it shouldn't be too bad, right? Now, once again, can you guys tell me the degree of this polynomial? How much you think it is? Degree 4, right? So it's an even degree. Right? So even degree polynomial, when it comes to the end behavior, remind yourself it will be something like plus or minus x squared, right? So it's like a parabola, but on the far right and far left. So it will have to rise on both sides or fall on both sides, right? But in this case, you have a negative leading coefficient, so it's going to fall, right, both sides. And it turns out that there's only one option that has the correct end behavior. You see that? And that's the option you should go with. You can always double check to see, oh, I have a 0 and -2, a 0 and a 2, right? And now, can anyone explain to me that why the graph touched the 0 at the origin and turns around? Even degree of that particular 0, right? And that came from the factor x squared, okay? All right, so now moving on. Okay, so that's a long division or polynomial division. So of course, you know, you try either number 7 or number 8, right? The right way, doing the divisions, make sure that you're putting the 0 to hold the place, right? But let's say, take a look at those options. Do you see that they all have the same exact leading term, right? And also, there are 3 options that has the second term identical, right? You can tell that most likely the answer is going to be from the first 3 options. But if you have to tell, you know, whether it's going to be A, B, or C, do you see any big differences among all 3? The remaining terms, right? And you might say, well, it looks to me that B and C are pretty much the same. No, there is a sign difference. See that? C has a negative sign, B has a plus sign, right? So now what you could try when you try, you know, maybe number 8 is to plug in some numbers. You know, you could even just do that right away without even, you know, trying the actual division. So say let x, you know what, try to be, you know, make the number as easy as I can. Can I try x to be 0? Would that cause any problem? If I take some x's, or let's say if I take all the options where x is going to be 0, it's fine. Do you guys see that? So if you do that, you can even do the mental math, right? So this guy's gone. -3 over -1, which has to be 3, right? So let's see one of those options, you know, better work out as 3, right? If you take x to be 0. Now, if you do that, that means those guys are gone. Don't worry about the x's, right? Even this guy. So now what you're looking at is the first guy, 3 over 49, wrong, because obviously that's not a 3, right? Now for letter C or B, then, you know, use the calculator, right? Just either add up 3 over 49 and 144 over, be careful, that's -49, right? Or in this case, +49. Whatever you do, right? So find out whichever it's going to work out as 3. And you know what? Letter C is correct. Okay. So, but that was just by plugging x to be 0. Okay. You don't have to, because, you know, you're not going to show me any work. Okay. But the right way to understand what's going on is if you can do it quickly through the division, right, in a minute or 2, you have 90 minutes for 25 questions. So I think that some of the questions like number 3, you could have just tell right away, right, spending less than 10 seconds. So you can safely, you know, spend maybe 5 minutes on this question if you feel like doing the right way, right? It's more comfortable. But if, like I always say, if it doesn't work out, then try a different way. And also, if you do have time to come back to a question like that, you know that's all it's all about. You you know, being careful with, you know, all the detailed work, right? Maybe use the calculator, plug in some numbers. If you feel like picking the C or a B, check it with setting you know, X to be 0. If somehow B doesn't work out, then you know that there's something wrong. Okay. All right, moving on. Now for this, I guess that I do need to remind you once again, because this is pretty much, you know, the rational zero theorem, right, or not. So you're finding the leading coefficient, right, and the last term, which is a constant. Okay. So in this case, what is the leading coefficient? 6, right? The constant is 2. The possible rational zeros, right? So will be from the list of all factors of A0 over all factors of A sub n. Please notice that A sub 0 goes to the numerator. Therefore, in this case, you're looking at for number 6, it has 1, right, 2, 3, and a 6. But when I say all possible, that means plus or minus, right? Should be included. Now A sub 2 is 1 and a 2, right? Those are the only 2 possibilities. Right? Therefore, you should be looking at either 1 over 1, right? 1 over 2, 1 over 6, things like that, right? So number 9, it will be letter B. Okay, pretty straightforward. You know, just give it a try. Number 10, then you know you should be good. Okay, moving on. Now, it's an equation solving problem, right? And as you can see, that there's some real zeros, some imaginary zeros. And also you can tell probably from the first 2 zeros, you know, which one's going to work out. But still, do you see that you first have to check at least 1 0, right, to see that if 3 or negative 3 is going to work out. If you do check it, let's say, right, negative 3 works out, that means you're going to looking at A and B, right? Then do you notice that 3/2 and negative 3/2, they're different? Try another one, right, to see if it works. But how do you check the 0? If it's a real 0, I mean, use the calculator, right? So now I think I did it, you know, so if you know how to do it, that's fine. But at least that let me have it recorded. Okay, so let me type up exactly what this is. So I'll go to y equals, right? So 2 times x to the 4th, okay, plus, right, minus 17 x to the 3rd, okay, plus 71 x squared, minus 153 x, right, minus 153 x plus 117. Okay, so that's good, right? Now, some people like to graph it to see, you know, the 2 zeros, right? That's fine. And sometimes you might not be able to see all the zeros, right? Because, you know, the graph is just too big. You can zoom and, you know, do the zoom fit to see the entire graph, right? But it's probably not very helpful. You can go back to Z standard. Okay, so I do see 2 zeros, right? So you can trace to see, you know, if you have a 0 somewhere around, oh, I see that it's probably 0.5, well, 1.5, right? So if you want to see that if 1.5 is going to be exactly the 0, you can type in 1.5 under the trace mode. It's going to go to exactly that point with x to be 1.5. Hit enter. It does tells you that y is equal to 0, right? That means this is indeed a solution, right? So that means, you're looking at, 3/2. Another one, obviously, it's going to be 3, right? On the positive side. So that's how you can tell from a graph if the graph is easy enough for you, okay? But you can also just literally evaluate the first two zeros, see if it works. And a way to do that is go to the variable, right? Go to the next column, right? The first option, function, and pick y1 since we typed the y1, right? Open parentheses. Now let's say type in, we know that 3 is going to work, right? Let's try 3. Hit enter. It is a 0, right? Then don't go through the variables again. Just go up and highlight the y1. Hit enter, right? Go back and change it to 3/2. Okay, check it. It's a 0. Okay. Now the problem is, if you decide to check the imaginary 0, that's not going to work if you do it this way. So let me show you. Here, if I type in 2 plus 3i, okay, close the parentheses. Now, I did type in everything correctly, when it comes to the I, and the calculator does know how to do, the algebra with the imaginary numbers, but somehow that the function mode, maybe I was wrong, if you figure out a way to do it, but it's going to complain, okay? But do you see that you don't even need to get to the imaginary zeros, right? So check the real zero, as many as you can. So if that's good enough for you to find out the solution, then, that's good enough. Okay. So again, you should have something as complicated as number 11, which is question number 12. Give it a try, either the right way, but then you have to go back, find the date that we did that in class, right? Go through recording. But I suggest that try with the calculator. Now, number 13. So for 13, I think that a lot of students had a little issue in our second test. So the questions might come like that, as something asking for the vertical asymptotes, or it may be asking for the domain, right? So in this case, it was asking for the vertical asymptote. So why don't you guys think about that for, a brief moment, and let me know which one you feel like picking. Some people might go with letter A, right? So there are two zeros, obviously. Oh, sorry, there are two poles, right? One at 0, which came from the factor of x. The other is -4, right? But what's happening with the 0? What's happening to the x, the factor of x? It got canceled, right? That means you don't have a pole at the 0 anymore, and it will be a hole. Therefore, there's only one VA, and that's x equals -4. Okay, so no calculation needed, most likely, right? There's nothing tricky at all. You just have to be alerted that there might be some pole 0 cancellation, so you might not have as many VAs as you thought. Okay. Now, 15, 17, 19, question including the corresponding even number questions, they're asking for the horizontal asymptotes. Okay. The way that we discussed finding how the horizontal asymptotes are looking at the behavior of the function once you drop the non-leading terms, right? So by non-leading terms, I mean, if you're looking at the denominator of number 15, 1 is the non-leading term, right? You don't need that anymore. Here, number 17, the denominator has a 1, right? Forget it. In number 19, turns out that the x squared and a 1, both of them are non-leading because you're comparing to the leading term, which is x to the third, right? Then you're gonna find out the horizontal asymptote. But in number 15, do you see that the degree on the numerator is greater than the denominator? Now, if you were to try that the way I showed you in class, you will realize there's no horizontal asymptote, right? Because of the I'm just setting an alarm for 11:35. Right? So for number 15, degree of the numerator is greater than the degree of the denominator. Oops. Denominator. You get what I'm saying, right? So the degree of a numerator is greater than the degree of the denominator, right? No HA. Right? It's going to rise or fall to infinity. Now, number 17, again, do the right way, then you see that the HA is what? Let me just it's 4, right? It's just the ratio of the leading coefficient, right? But that only works if you have the degree of the numerator exactly equal to the degree of the denominator. Okay? Ratio of the leading coefficient. The last one, degree of the numerator is less than degree of the denominator, right? There's still a VA. That's right, there's still a HA, but it will be y equal to 0. And the way you can understand it is the denominator has a higher degree. That means it will grow much faster, become much bigger than the numerator, right? That means you have a, relatively speaking, a infinite large denominator, which makes that function become infinite small, right? So I'll say that those are the only 3 cases for the HA, okay? So at the end of the day, you're comparing the degrees, right? And you do have to find the HA by finding the ratio of the leading coefficients only when the degree of the numerator and denominator are the same, okay? So let's see, probably one more question. Oh yeah, that's something I believe that you might have to do some math, which is unfortunately the division, okay? So let me just do that so you can have the work to refer to and later maybe try 22 to see how that works out. So the slant asymptote, okay? So none of the options says that there's not going to be a slant asymptote. That means it has to have one. But it does work out since you have a numerator which is actually 1 degree higher than the denominator. All right, so what you do is take that numerator x to the third, but I suggest that you do make your work a little bit readable to yourself sometimes by holding the places for those missing terms. 3, 2, 1, 0. Okay. Then we have x squared plus 2x, right? No missing terms. So you're going to start from the leading term, x to the third, divide by the leading term in the divisor. So you're looking at x, right? Coming back, you have x to the third, right? But make it opposite. Then 2x squared, but becomes negative 2x squared. All right, so add up, those cancel, right? So you have negative 2x squared, right? If you can bring it down next term, right? Do it again. Negative 2x squared divided by next x squared, you're going to get negative 2, right? Now, no need to proceed anymore. Do you see that? This is already the slant asymptote. Because all you have to do is find out the quotient. You don't care about the remainder. So once you get a quotient, since you only need the linear term and a constant term, the linear term is not going to tell you anything. It's that additional constant term that tells you which slant asymptote is. Okay.